Okay, in this video, I will try to solve the leetcode question 128, longest consecutive sequence. So the question is given an unsorted array of integers nums, return the length of the longest consecutive element sequence. The requirement is that we have to write an algorithm that runs in linear time. So let's look at the example here that was given. We have an array of integers 100, 4, 200, 1, 3, 2. So looking at it, we know that the consecutive elements in this array of integers are 1, 2, 3, and 4. So as a result, we have 4 as the output. In the second example, we could see that we have 0, 1, 2, 3, 4, 5, 6, 7, 8, and we don't have a 9 here. So we could see the longest consecutive elements here is 9. And example 3, we can see 0, 1, 2. So that's the result. We have output 3 here. Now that we understand the question, I'm going to try to solve this question in a brute force manner first to understand as a simple solution, and then that algorithm would not be in the linear time. But after we solve that, then we could explore algorithm that could solve the question in linear time. Okay. Okay, so what comes to my mind would be to sort this array here. So if we were to sort the array, it would become 0, 1, 1, 2. So after we sort the array, we could simply loop through the array, starting with the 0 index, and then we could check that if the following next element is the consecutive number. So how do we do that? We just increment this element by 1, which will give us 1. Then we compare with the next element. So this will give tell us that the next number is the consecutive number. Okay, and then we could do the same thing for the subsequent elements. So 1, if I increment by 1, will give us 2. In this case, we realize that the following element is not a consecutive number, but it is a duplicate of the previous element. So if there is a duplicate, we could skip it. Okay, and then we could compare with the subsequent element here, and then if it is a consecutive number, then we could keep track of the count of the current consecutive number. So in this case, we have a few conditions. If duplicate will skip, and if the current element in the index increment by 1 is equivalent to the next index, then we could say that this is a consecutive number. And there's another situation we need to handle. If the if let's say I add 5 and 6 to this array, then if 2 increment by 1 would be 3, and we compare 3 with the next elements, we realize that it is not a duplicate, and it is also not a consecutive number. That means we could say that 5 is the start of a new consecutive sequence. So in that case, then we could reset the counter and then recalculate the longest sequence for that new sequence. Okay, so the next condition would be to reset the counter and recalculate new sequence. Okay, yeah, I think that would be the main algorithm here. Okay, let's try to implement this in Java. So we will have I will start by initializing a few variables here to keep track of the uh, uh, consecutive count in that sequence. So I will just say this as a current count, and this is basically the current count of the consecutive numbers. I will have another variable here. Let's call it max count. This is the maximum or the longest. Let's call it the longest count. Okay. So the longest count is the longest consecutive number seen so far. The current count is the longest consecutive number in the current sequence, in all sequences. Yeah. So the longest count is basically the count to keep track of the longest consecutive number seen in all the sequences. So for example, here we have two sequence, right? We found here 0, 1, 2 is our first sequence. So this will give us let's say so we will increment, so there is 3 here, right? 0, 1, and 2. And here we will have 5 and 6, so it's 2. So at the end of the day, we will return 3 because 3 is the longest consecutive count. But we do see 2 sequences in this array. Okay, so okay, then we will have the next variable here. Do we need another variable? No, I think we can just return the longest count after we run through the algorithm here. So the algorithm, first we need to look through the array, starting with the 0 index. So here we need to make sure that we don't exceed the end of the array. Hence we need to minus 1 here. And then we could okay, so our current count and our longest count needs to start from 1, because after we increment by 1, then we will increase our current count. So in this case, if we were to start with 0, if our index were to start with 0, then when we found that there is an increment from 0 to 1, we will add 1. Then 1 to 1, there's nothing to add. Then 1 to 2, we'll add another 1. So this will give us 2. Now this is wrong because there is actually 0, 1, and 2. So total there's 3. So in order to include that, we have to start our counter as with 1. Okay. So once we understand that, then we could start with the algorithm. First, we need to check for duplicates. So if I think let's break down the current num here. So current num would be the elements in the I index, and the next number would be the elements in the following index. So if our current num is equal to our next num, then we could skip this, and we could continue to check the subsequent elements. And if the subsequent element is the consecutive number, so current num plus 1 is equal to the next num, we could say that this we found a consecutive number. And if we were to find a consecutive number, then we could increment our current count, which is the tracker for our longest consecutive number in the current sequence. As we increase our current count, we could reassign our longest count with whichever the bigger number is, so current count or the longest count. Okay, so else is when it is not a duplicate. Like for example, 2 to 5 is not a duplicate, and it is also not a the consecutive number. That means it could be a start of a new sequence. So in this case, we need to reset the counter, and then we could start recalculating the new sequence. So that means we could set our current count to 0. Current count to 1. So this will help us to reset the counter. And then the following next index will help us to basically recalculate the sequence again. Okay, yeah, I think that's about it. Let's try to run this. Okay, so there is a failure here. Okay, so first thing first, we need to sort the array. So in this case, array.sorts nums. Then we could do the following logic here. Before that, we could also check for one thing. If the elements if there's no element in the array, then we could just simply return 0. Okay, so all the 3 cases passed. Let's submit this. Yeah, so it took us 21 milliseconds. I don't think this is the best result. The question wants us to solve in linear time, but when we do the sorting of this array, it is taking logarithmic time. So we have logarithmic time, and this is definitely worse than linear time. I think we could I'm gonna end this video here. And in the next video, I will try to solve it in linear time.